I'm just going to introduce Venn diagrams because they're so useful in helping to solve some types of probability questions. So we can see here a Venn diagram, and the rectangle represents the sample space of the experiment that we're interested in. And contained within this rectangle are closed curves, and they represent events. Now we're going to use a little bit of set notation, and a lot of what we are trying to do when we deal with Venn diagrams is to identify areas within the Venn diagram that we're interested in. So if I was to ask you to identify the area that's associated with the outcome A, probably wouldn't have too much difficulty in seeing that this is the area that we're interested in. But here we're asked to identify the event A intersection B, and in plain English this is the overlap between A and B. It represents the event where both A and B occur, and that would be this area here. And here we're asked to identify the event that's the union of A and B, and we use this U symbol here. So this is A union B and represents the event that either A or B occurs or both occur. And you'd probably be able to see that this is the area that we're talking about, the union of A and B. And we use a little dash here to show that we're interested in the event not A. So one way of looking at this is, if this is A, then we're interested in everything else. In other words, this area here. And you might recall from work previously in probability that the probability of not A is 1, which is everything minus the probability of A, and you can see how that works out here. We want the probability of not A, so that's just as we did previously. You can see that would be 1 to represent everything less the probability of A, and that gives us not A. And here's an interesting one. This is the event of not A intersecting with B. So something that where not A overlaps with B. Now this can be a little bit tricky to visualize, so I'm going to put in another sample space here just to demonstrate on this video what's going on. So we know, we'll look here at the first one at not A, which is this here, and I'll look at the event B, which is, and we want to look at the overlap between these two events, because the intersection represents the overlap. And by comparing the two, we can see where the overlap occurs. It's just this here. So just that space there. That is not A intersecting with B.